I know we did moraines until, did we do drumlins? I think we did. Where's erratics? Oh, okay. Oh, so we did not get to drumlins. All right. No problemo. Salud. All right, so we were talking about glacial debris. And we gave you a generalized term for all the unsorted sediment that just gets dropped by a glacier as it melts out. Typically at the end or along the sides of the glacier. We talked about moraines. And now we're going to talk about some random features that get left behind, again, once the glaciers have been long gone. We talked about erratics as the large boulders that are just there. So the outwash plain. The outwash plain is the area in front of the glacier. It's not really a vocabulary word so much, but just, that's what we talk about, or that's what we're referring to, where everything is washing out. Outwash. So there's a couple things on here. You see the more or less horizontal structures in front of the glacier. Those are old moraines. And as you might think, when the water's coming out of there, it's going to move that sediment around. And it does some other things. There's another vocabulary word for sorted sediment in front of a stream. We're not going to worry about that. But we do want to add in drumlins and eskers. You see those two words closest to the stream, closest to the glacier, all right, as a couple features. And also I do want to mention the kettles, the kettle lakes there that you see. If you remember us talking about calving, these giant hunks of ice falling off and basically floating away as icebergs and so on and so forth. Well, oftentimes, and this is kind of hard to imagine, this is the reason I like to talk about it, is that those things are big enough to actually leave a dent in the lake bottom or whatever you happen to be dropping ice down onto. And if it's relatively dry out, they're going to fall down and boom, get stuck in there and melt. They leave lakes behind. Okay, it's so much massive ice, and it falls into that wet, nasty ground in front of it. It leaves a huge impression. Imagine, hitting something with a BB or something like that. It's going to leave a dent or a ding, right? Well, this is just the weight of it dropping actually carves out a big old hole, and then it stays there and melts, or it fills up later. Doesn't matter. You've seen these if you've ever traveled with your family or whatever to the Cape Cod area. And a lot of folks there, usually the locals, but sometimes visitors, they tend to stay more inland. They've got so many kettle ponds there. It's unbelievable. And they go there. They don't go, if you've been to Cape Cod, the water's frigid, unless you're on the north side of the island there. It's much shallower on the bay side. But the ocean side, oh my goodness, it's cold. So they go to these kettle ponds, and they're scattered all over there. So it's a big feature. And I'm sure we have some around here, and I just don't know them by name. Because, again, we had glaciers, dropping stuff here as well. Eskers, all right? An esker is formed. You see these braided streams coming out the one side of the glacier here. An esker looks like a stream, right? And usually we think of streams as wearing away, weathering, carving a valley. But in this case, I guess because there's so much sediment, you've got the weight of the ice on top of you, it leaves a deposit instead. And it leaves this snake-shaped, this esker, the snakes. And it is a stream deposit, okay, left by a glacier. Probably gets the sediment from the moraine that it ran over. Drumlins, much similar way. All right, drumlins is supposed to think of like a drumstick, a turkey leg, picture that, or the drummy on a chicken wing. And these don't exactly look that way. And in reality, they don't necessarily look that way either, but that's what they're referring to. And this is reworked moraine in an elongated direction. And you're going to see some pictures in a moment, both like on a topographic map and just another image. They could use these thousands of years later to show the flow direction. They figured out that it's going to sort of be sloped down and narrowed in the direction of flow. So these things, let's say they're all sort of oriented northwest. That means the glacier, for whatever reason, went northwest when it did, and as it was receding as well. So it's flowing back over, and it carves these funky little shapes. I shouldn't say carves. It deposits these funky little shapes. It's carving through the moraine. It's a little confusing, probably due to my explanation. I apologize. So, drumlin formed when a glacier plows over a moraine. Just said that. You get these elongated hills, the gentle downstream slope, and steep upstream slope. I'm going to show you that instead of, and if these PowerPoints aren't up, please email me and tell me to put it up. I think I put it up. So here you see the sloping narrow is in the direction of flow. They got all those arrows making sure you know the direction of flow. And then the steeper backside is uphill. And these are relevant because you've got these all along 81 south going out of Syracuse. Coming out of Syracuse, and I've tried a handful of times to take these pictures. It just looks like green hills or snowy hills, depending on the season. You can't get this view from ground level, especially doing 65 on 81. If you're lucky enough to fly out of Syracuse and heading south, okay, and you got a window seat, and you time it just right, you might be able to see what we're talking about. I'm told, I've read, that 81 South is littered with these all along that corridor down to Binghamton. Okay, the whole way. They look like gentle rolling hills from the road. But what you would see is that if you're heading south, that these slopey things, you can see from the contours. See how they're closer together on one side? You guys learned in lab that when contour lines are close together, it's steep. When they're farther apart, it's narrow. I'm sorry, when they're farther apart, it's a gentler slope. So we see that they're steep backed and they slope outwards and they're kind of pointy. So neat things. And again, we saw fields of them back in the day, again, probably from up on another mountain or another hill. Otherwise, you would just wonder what all these, rolling hills were. So there's the esker. We said it's a meandering ridge of sediment formed under a glacier from meltwater. There's a picture of it on the next thing. And I guess it is important, I didn't mention it though, that did say sorted sediment. So because water's flowing, it's formed by flowing water. But again, I did not give you that term for sorted glacial sediment. You got too many terms already. But remember, water sorts. So this isn't really a great example of anything other than the mess that's in front of a glacier. Okay? Just a whole bunch of wet, soggy stuff, all kinds of braided streams, some puddles, Kettle Lake right there. You got all kind of just debris. And it's a great foggy day on top of it all, just to add to the desolation and general mess there. These are neat. It's hard to see in this picture. We're going to give you a much better picture in a minute, but you see those white sort of streaks going through there? They almost look like eraser marks. This is a weathering feature. We've been talking about deposits for a couple minutes now. This is a weathering feature. Those are, as it says, grooves. Those are gouges in the rock made by the ice flowing over it, and there's like a pebble, or depending on the size of the groove, something bigger, cobble, boulder, sticking out of the glacier, and it's basically a key job on side of a mountain or the rock, whatever it's sliding over. And, these elongated gouges, people noticed them over the years, and we came to figure out what they were. Many of them are as small as pencils. Some of the ones I've seen would look like, you guys don't have them, no, you got one on your desk there. Those little ridges at the top that you're supposed to put your pencil in, okay, so it doesn't roll away. Looks like about that width. Some of them, however, can be significantly larger. It's hard to get scale for a moment. You see the fence in the background, that helps a little bit. This is like water slide diameter. These are big. This is not my picture. Last time I was there, we did not have cell phones. I'm sure I have a paper photograph of it somewhere. If you're familiar with Cedar Point or ever heard of Cedar Point, this is just north up into Lake Erie. There's Kelly's Island and the Bass Islands are there. It's sort of the equivalent of you guys going up to, oh my God, I just jumped out of my, up past Watertown there on the St. Lawrence. Thousand Islands. What's the town there, though? Alex Bay, yeah. All right, it's sort of Ohio's Alex Bay kind of area. There's all kind of wineries up there. And back in the day, they rented golf carts, and everywhere had horseshoes. And golf carts, horseshoes, and wineries, really not a good mix. But it's what they did on nice warm weekends, and it was lots of fun. If you took another boat to Kelly's Island, it was much calmer, cooler kind of area, much more natural, and this was out there as well. So somebody saw these as they were, doing some development on the island. Probably didn't know what they were, but knew enough to say, hey, we better call the head engineer or whomever. And, they got a fence put around them, and to my knowledge, they're still preserved over there. You don't see them this big very often. There's some in Central Park. I think I used to know where they were. When we did Geology 102, we would walk from, we'd take the trains out of Poughkeepsie and go to Grand Central, get off at Grand Central, and we'd stay just across the street at a really awesome hotel, Grand Dame of Manhattan. And we'd walk to the Natural History Museum on Saturday morning. Well, we'd cut through Central Park and we'd stop. There's a lot of cool rocks in Central Park if you've not been. But I don't think we ever, my point being, stopped and saw the glacial grooves. So I should have added that, and sadly we need like 7 or 8 people to get Geology 102 to run, and that's hard to do anymore, especially when they don't even list it. So I got 2 people that want to take it as independent study in the spring. So if you've had geology already, or nudge nudge, take it this summer, and maybe we can get half a dozen more people. Maybe they'll actually run the whole class, which would be really cool. We have to talk about fossils and evolution and stuff like that. Sorry for the shameless plug, but it reminded me Central Park. And then we could go and see glacial grooves in Central Park too. Wouldn't that be fun? But at any rate, so they're rare. Okay, there are a handful of places that have them, and they're a cool feature. Calving, I kind of thought we talked about calving already. I've given this lecture 3 times already this semester, so everything's a little askew. Calving is what happens when the ice, hopefully mentioned, they always talk about Antarctica. The ice sheets are breaking off, falling apart. Okay, it's not the rock. Antarctica itself isn't breaking apart, but these overhanging ice sheets are breaking off, some of them quite huge. Well, bits and pieces of that break off. That's where we get icebergs. Okay, as these ice sheets fall, they float away. Sometimes if it's from a great distance, as I mentioned with the Kettle Lakes, they fall. They make a big ding in the bottom. Here we've got drop stones, not big enough to form Kettle Lakes, but apparently they leave enough impression in the geologic record that they get acknowledged. So calving, if you want to pronounce the L, is the process of iceberg formation. Okay, as in like cows giving birth is calving. I believe already I mentioned again, sorry to keep saying that, but that a lot of our terminology for glaciers comes from shepherds. All right, these folks that had a whole lot of free time to sit around and watch this stuff happen. So, and make these observations. So they gave it a word that they were already familiar with. I don't know if it was the sound or the look of it or just that the glaciers were giving birth. I don't know. And my favorite. Very few times we get to put the letters F and J next to each other and make it sound like a Y. Fjord, right? Everyone knows fjords. And fjords are really awesome for a handful of reasons. First of all, they're absolutely beautiful. Second of all, because they support, for those that still don't quite get it, the idea that sea level has risen and fallen so many times in the Earth's history. We've explained to you already that to make all this ice, we had to pull water out of the oceans. When you pull water out of the oceans, guess what? Shorelines are a lot further away. Okay? All your favorite beach places are now an hour inland, for example. As a result of that, the glaciers traveled a lot farther. Rivers, everything, traveled a lot farther before they hit the sea. Rivers doing their thing, carving valleys, so on and so forth. Glaciers doing their thing, carving valleys, so on and so forth. They gouged this stuff all the way out to the old coastlines. Jump ahead a couple thousand years, sea level rises. Inundated means flooded. All right? I am inundated with requests for grades because I'm behind in grading. I'm flooded with requests for grades because I'm behind in grading. Inundated is just a fancy word for flooded. You get that. All right? So, again, remove the water. That valley goes down. These are usually quite deep, let alone the steep part that you see. They make amazingly cool places. You probably got your Princess Cruise Lines vessel in there. Just give you a little bit of scale. Got that lovely village down there, which has probably been there for 1,000 years. These were inlets, okay, for another word. This is a little high to picture, people up at the top dumping vats of oil down the side, or at least shooting catapults down on people trying to invade them. But again, you get the scenario. This would have been a really cool place to set up a settlement. But you get a lot of snoopers too. People traveling along the coastline saying, hey, what's up this way? But really, really beautiful, if nothing else. As the spelling might imply, you see a lot of these in Northern Europe, Scandinavia, that kind of area. Iceland, Finland, whatnot. Pretty sure there's some in and around Alaska and Canada. I think Alaska. I'm not sure about Canada. We got Alaska on the west coast, Canada on the east coast. So fjords. All right, and that ends the random barrage of glacier-related terms. Segue into the rest of the conversation, the ice ages. So when I say ice age, you get an image in your mind. Thanks in a large part, which is totally fine, to those silly movies. Okay? I watched one or two of them. My son at the time really didn't dig that stuff. So we didn't watch too many of them, but I love that silly little squirrel, as I always say, and the misadventures that he gets into. But I don't know too much about the interactions of the rest of the characters. I know who they are. But that's what you guys think of when you think of ice ages. And again, that's okay. The selection of animals is pretty accurate. The fact there's a human wandering around is fairly accurate, and so on and so forth. We'll get to humans by the end of this lecture. But, technically speaking, there were many, many more ice ages before that one. That was just the most recent one, and that's fine. That's what we have the best evidence of. But there's plenty of evidence of ice ages well before that. We did watch in here, correct? The video about New York State and ice ages? Okay, that's another one where I've shown too many times to keep it straight. I never, as it turned out, ended up showing that to my geology students. So you saw what was here. You heard about a couple of the critters, the mammoths, the mastodons. We find evidence of them. There were other critters that aren't around nowadays that were here. There were humans here. So an ice age is a long interval of time, where global temperatures are relatively cold and large areas of the Earth are covered by continental ice sheets. Remember how we started this conversation? Now we only have ice sheets at the two poles. And alpine glaciers. What more or less happened is not just the ice sheets from the poles grew, but the alpine glaciers came down as much and grew onto the land too. It sort of merged, and it was a group effort, to say the least. Nowadays around here, not even here, in North America, and Europe and Asia and whatnot, we're looking primarily just at alpine glaciers being left. Again, you want to see the sheets, you got to go down to South Pole, North Pole. And North Pole, as we discussed, is melting fairly rapidly. What you probably didn't know is that there's a lot of bouncing around in an ice age, in quotes. You've got these subcycles, if you would, where the temperatures actually go up, what we call interglacials, and where the temperatures go back down, where we call glacials. And you've heard me lie to you several times when I said the ice age ended about 10 to 12,000 years ago, depending on where you live. That was a lie because most folks feel that we are in interglacial period right now. And I'll show you evidence as to why they feel that way. But it was just simpler to lie to you. I apologize. You've probably said that yourself so many times. It's just simpler to lie. And sometimes that's true. Not all lies are, equal. Your 100 classes lie to you a lot. You get up into a 200, 300, 400 level class. And they'll say, okay, remember how we told you? Well, that's not really true. It happens. So before we get into the details of that, there have been at least 5 major ice ages throughout Earth's history. The earliest one that we have record of was around 2 billion years ago. Now I'm going to tell you that we know things about these recent ones that we're going to talk about because we've got bubbles trapped in the ice cores that we look at. Okay? I'm pretty sure we don't have bubbles in ice cores that are 2 billion years old. They're looking at more indirect evidence like the moraines, like the weathering and the various things that we spent the first half of this lecture talking about. That's the kind of evidence they have for these older ice ages. And something else to keep in mind, we didn't talk about it in here, but plate tectonics. The continents have not always been where they currently are. You know that, but you don't know that it's relevant necessarily. You remember Pangaea was assembled. At some point, Pangaea broke apart. All right, well, there was a time before that. There was a time when there were other supercontinents. And they had other names, and so on and so forth. They just don't generally teach about them. So when you're going back 2 billion years, and a lot of that time in between, Pangaea was 400 million to 250 million years ago-ish? No, 60 million years. So I think it was 250 to 60. Forgive me for not pulling that number right out of my brain, but it was recent, geologically speaking, okay? The Earth is 4.5 billion years old. So there were continents and supercontinents several times before that one. That isn't exactly a lie your teachers told you about. They just told you about the most recent one. So anywho, when you look at these places and you're able to help reconstruct things like that by thinking, okay, where was this continent when that was happening? It complicates it a little bit ago. So as you guys all saw and frantically scribbled down into your notes, we're going back roughly 2 billion years to as recently as 3 million years ago. All right. Now, the glaciers weren't here 3 million years ago. Remember, they had to grow down. It takes time. It takes time. So here's some records here. This is, I've got all my references at the end of the lecture here. So a simplified chart showing when 5 major ice ages occurred in the past, over the past 2.4 billion years. This is modified, and I love how he says this is simplified. It actually is kind of narrowed down here. You see global average global temperatures on the left side, and just millions of years ago on the bottom. You're going to see some slightly more complicated ones. But you see those big dips, okay? Those big dips are the ice ages. And you got our most recent one, and you see here that, we're actually on an upswing here. But these, again, in the scale here, it's kind of hard to see. They're big chunks of time, and we'll talk about this a little bit more here as it gets there. So again, the idea is, by the folks that are in charge of thinking about this stuff, that we are in an interglacial that began, as I said, about 10 to 12,000 years ago. Depends where you live. I picked an average number, 11,000 there, for conversational purposes. The last ice age, or the ice age as most people refer to it, peaked at about 20,000 years ago. So when you see some of these maps that are coming up here, the maximum glacial extent was about 20,000 years ago. So again, when you're thinking about time, you're looking at about 8,000 years. 10 to 8,000. It depends. A little less than 10,000 years to melt back. So remember how I told you it had to grow. Well, it also takes time to melt back. Now, where do they get those numbers? Obviously, we weren't taking data back then. You've heard about the ice cores. I referenced this a moment or two back. Okay, we drill down. We've got really old ice. It piles up, and it, at least in recent times, hasn't been melting away. There's something you learned in earth science in high school called principle of superposition. Remember that? The oldest stuff is on the bottom, youngest stuff is on top. Just makes sense, really. So the farther you dig down in the ice, the farther you're going back into the Earth's records. Just like ice cubes coming out of your freezer, there's bubbles in this ice. Those bubbles are snapshots of the air when that ice froze. They can actually suck that gas out, for lack of a better word, and do a test on it, see what's in it, see what ratios of what to what are in it. And then based on other stuff that we already know, that's how they're getting things like probable temperatures and stuff like that. All right, they're not making this crap up. I've said that several times over the years, over the semester, let alone over the years, that, people want to fuss about and argue about and so on and so forth. They have data, okay? Yes, there are extensions of that data. Yes, there are predictions based on that data. And yes, sometimes predictions and extensions are inaccurate. But generally speaking, that's sort of the point of science, going all the way back to the first conversation we had in here. We collect data and we make statements about it. So that's where this stuff comes from. All right, for about the last 2.5 million years, that's pretty much what we call our ice age. I know it said it started, a higher number on a couple slides ago. All right, but 2.6 million years ago, This is basically our Ice Age period. It's a long time. This second bullet really could have 3 slides with it, 4 slides with it. Something called the Milankovitch cycles you may or may not have heard of. I ignored them for most of my professional career because I just thought it was some crazy hypothesis. And I think even when it was presented to me, it was the Milankovitch hypothesis. I don't know. I think it might have been bumped up to a theory by now. But regardless, he talks about some irregularities in the orbit of the Earth and irregularities in the tilt of the Earth. And they do add up enough, and combined with some other information that I recently learned, like that, you know how they always tell you that the orbit of the planets are elliptical. They're not a perfect circle, right? They're an ellipse, which means there's 2 focus points. Well, between Jupiter and the Sun, we have sort of the same situation going on because Jupiter's so freaking huge. It exhibits a gravitational pull on anything that's between that and the Sun. And aphelion and perihelion aside, which again, 2 words you learned a long time ago, closer to the Sun, farther away from the Sun, there's even bigger cycles where because of Jupiter's pull, we go out even further from the Sun. So cycles like that lead into things like this. That's why, arguably, you know, again, if you look at those records, they are every X number of years. They're cyclic. And these interstitial periods that we see between the glaciers coming and going within those cycles, so the smaller cycles within the bigger cycles, are generally speaking a whole lot longer than 10,000 years, which is all that we've been out of our glaciation. So that's where the idea, the premise, then, that we are just in an interglacial period comes from. Now, so what? Al Gore and Bill Nye and Woody Harrelson, they're all just freaking out about nothing? No, they're not. All right? Within those cycles, again, remember, we can see the air snapshots over all those years. The CO2 that we've been pumping out in the last couple hundred years has totally hijacked that scale. Is it enough to keep us out of going back into another glacial period? That we'll see. We are warm, and again, they say we're warming faster than ever before. How do they know that? They've got those records. So we'll see on that one. There's no question, again, that the ice isn't melting right now. But whether or not it's accelerated, well, no, we know it's accelerated beyond. The question is who's going to win this war? Is Mother Earth more powerful than us, or are we powerful enough to throw her off kilter? We've already seen that we could put a hole in the ozone layer, and by stop using that stuff that made the hole, that hole would regrow. So there's hope for this whole carbon war as well. So when these people, just like they tell you when you go to the doctors, you kind of have to exaggerate your symptoms in order to get attention. Okay? I'm not saying that they're exaggerating the situation, but you do have to talk about the worst case scenario in order to get people's attentions. It helps. So you hear a lot about that. But again, it's not made up. We have evidence. We see old coastlines in and out. We see this evidence and that evidence. We've got snapshots of the atmosphere. They're not making this crap up. They're just sort of hedging on one side in order to get people to pay attention. It has done this. It can do this again if we're not careful. So don't go out there and buy a whole bunch of V8s and so on and so forth because I said Mother Nature's stronger than us. Not my point. All right? Do what you can. You're not going to power New York City on solar and windmills, though, either. We got to find something. So it all works out, and it's all, again, this is environmental science, so you guys get a slightly different lecture than my geology or my earth science gets. Okay, because we've got more of that angle. We didn't talk a whole lot about people messing with stuff this semester, so I've got to get some of it in now. Here's a slightly more complicated graph. I'll read it to you. It's kind of small print. This just has more lines in it. There's another one that's got an oxygen isotope in it on the far thing, so they're actually plotting three things. But this is nice because it shows those interglacials. Kind of like when you zoom in at, I don't know, you guys probably don't own stocks, but if you follow the stock market, you're going to see some general ups and downs. But if you zoom into a better scale, you'll see that that up has 23 ups and downs in it. Okay, you know what I'm talking about? So that's what this does, is it zooms in a little bit to show you all of those ins and outs, those interglacials and those glacials within the interglacials and the glacials. So 4 fairly regular glacial interglacial cycles occurred in the last 450,000 years, which gives us about a 100,000 year cycle, right? The shorter interglacial cycles, which is the warm periods, last 10 to 30,000 years and are typically about as warm as we currently are. Those alternated with longer 70 to 90,000 year cycles. Again, depends if you're on the 10 to the 30. You're going to be 70 to 90. Glacial cycles, where it is substantially colder than it is now. Notice the longer time with jagged cooling events dropping into the colder glacials, followed by the faster abrupt temperature swings. The warmers tend to come rather abruptly, they've noticed. Like it's a more drastic, the cools are gradual, but the warm-ups are pretty extreme. That's what they're saying. Ice core records, blah, 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 blah. Yeah, so this guy is just citing his work, you know, and I'm citing this guy. Arguably, you should go back to the original article. Your teachers in English probably don't like it when you cite someone citing someone, right? But this is this guy's research, so he's telling you right here who he's pulling from. I'm not presenting a professional paper. I'm talking to you guys. So we're ignoring that sort of citation problem. So let's not talk too much about all that stuff in the past. Hopefully I've convinced you, not that you need it convinced, but that ice ages have been things going on for a very long time. So the most recent is what they call the Wisconsin period. It ran from about 75,000 years ago to 11,000 years ago, but we didn't see anything in that 75. Again, that was way north, way north. So that was the Laurentide ice sheet. You heard about it in the video. If you weren't here the other day when we watched the video, not only is there a worksheet with points attached to it, which you probably want, but there's some pretty cool stuff about the area in which you live. Okay, talks about some of the high peaks east. It talks about all the stuff around here, not just Finger Lakes, but all kinds of neat glacier stuff. And many of it you've been to, some of it you can go to. So I really recommend watching that video. Covered most of Canada, the Midwest, and New England. It went as far south as the Ohio River. Here it is. Again, it takes time for that to grow. So it wasn't just, poof, there's a glacier all the way down here to southern Ohio. All right? That had to grow. There's a lot going on here. We do have some other views of this, so you could get it in. It's kind of, I don't know how well it carries to the back of the room, but there is a lighter blue area off the continents there in the ocean. I believe that is an implication of the old continental margins. Okay? Not positive. That would be fairly accurate if it were. So that's why I'm guessing that that's what it is. See your Great Lakes, if you're still trying to find yourself, your Great Lakes are right in here.
So for New York, that little southern spot, that's the Susquehanna River. Like in southwest New York.
I'm going to say sure. I don't know my rivers very well.
Oh.
Susquehanna bob in and out of PA. To me, that sounds like a PA river. I grew up, bless you, I grew up in Ohio, very close to PA. Susquehanna was definitely a word I heard a lot, but I didn't know that it peaked into southern New York. So if you know that it does,
I know a little bit.
All right, so I'm gonna say yup. But no, and I'm actually looking at this. I lived a good bit south of where that line is, and I know we were glaciated. And I know there were places in PA, one called Moraine State Park, my folks took me to when I was little, that was full of moraines, obviously. Not going to argue with this graphic, but there's some fluctuation down there. This is kind of, I'm still deciding if this is useful or not. Again, I just wrote this lecture last week. You guys are getting a prototype lecture here. This second half is all brand new. So we've got our Great Lakes here, okay? Lake Maumee, I actually grew up in Maumee, Ohio. It's outside of Toledo. That's kind of cool that there was a paleo lake there. So we go from 14,000 years ago. The ice sheets were still very close. To 9,000 years ago, you see how far back they've moved. Ontario, your lake, okay, our lake, my lake now. Again, I grew up with Lake Erie, moving from one side of it, the west side, to the east side. Cleveland is on the east side, if some of you know where Cleveland is. I was south of Cleveland. Anywho, by 9,000 years ago, pretty far back. 7,000 years ago, even further. 4,000 years ago, long gone. So when we tell you that all the features around here are roughly 10,000 years old, this is why. Because that snowplow cleared everything out. All right. Yeah, you could up that to maybe 12,000 years ago when you want to talk about the Finger Lakes. It's fine. But somewhere in that couple thousand years, all these features are post-glacial. That's how old they are. So your streams that you visit, your creeks, so on and so forth, they're all good. No older than 10 to 12,000 years old. There's another view, the same thing. And this is one that dips down a lot further. This goes back to that glacial maximum. I think this previous slide maybe wasn't showing the maximum when I was telling you it didn't go down far enough in Ohio and or into PA. This one accounts for that. That KA is 1,000 years ago. You might have seen, remember, like MYA and BYA for billions years ago, millions of years ago when you took earth science. So KA is 1,000 years ago. Yet another view. Everything is North American-ocentric, so let's look down. Just to point out that these did grow down, and Asia and Europe were affected by this as well. Not just good old US of A. Again, and something we're going to touch on in a moment, we've got the old coastlines indicated. Okay, very rough lines, but the idea is there. Take all the water on the land to make ice. It's got to come from somewhere. Hydrologic cycle, water cycle, we talked about it. I hope we talked about it, right? Yeah. Okay. End of the semester, it's starting to catch up on me. All these different lectures, different classes. Same lectures in different classes. You've probably heard that the Finger Lakes used to be rivers, okay? They used to connect to whatever Lake Ontario was back then. Glaciers came through, they buried part of it, they gouged the hell out of some other parts of it. Ithaca is gorgeous, as they like to say. These Finger Lakes are long and very, very deep. Why it chose to deepen them instead of widen them, I don't know. Okay? And I did do a little sign reading when I was there, and I don't think they went into that. But they do like to point out how deep they are, and if you've poked around on those lakes, you know, arguably people say, well, if it's 100 feet deep, ain't no difference if it's 500 feet deep. It's still not going to, you know, get your Apple Watch if you drop it down there or whatever. But something about being, you know, super, super deep that's a little unnerving. You know, and they did arguably get gouged out a little bit widthwise, but not compared to depth. So, but that's the feature that most of you grow up knowing about, but there's so much more. All right, so this one does both. So this one, we've got three coastlines. We've got the current one that you probably recognize, but it's the slightly darker shade of, where's my mouse? Slightly darker shade of blue here, where we actually have, Florida, Georgia, your Carolinas, all right, Virginia, where we have those states. Then we see outwards the lighter blue area, and this is what I was talking about on one of the earlier maps, where when you took the water out, the coastline extended that much. So those places were not the coast because sea level was lower, and there were other condos and whatever up back then, I'm sure. However, if we carry on the current trajectory and sea level continues to rise, these are the projected coastlines. There's no time stamp on here. Again, they want you to freak out about this a little bit so you actually do something. Okay? My wife, bless her heart, doesn't want to move south because sea level rise. I'm like, honey, you have a bachelor's in geology. You know that she's a non-practicing geologist, as I like to say. But you see this stuff happening, you know the rate, but you hear all the hype in the news, okay? They blow stuff really out of proportion. Sea level is rising. If you're already in an area where the rise is a thing, it is just going to get worse. But not bad enough. You know, she's picturing this in her mind. This is a long time from now. But still, if we could prevent it from happening, if it is because of something we're doing, it would be great to fix it. At least try to mitigate it. We fixed the hole in the ozone, we could maybe not do this. Now again, Mother Nature is in control. Why do I say that? Because I've got another map that I should put in here. But if you go down and you look at the wall outside my lab, there was a giant, all through here, was flooded. Okay? At one point. You're surrounded by limestone. New York State was under the ocean. Sea level can get a hell of a lot higher than this. From the Appalachians to, like, what's in the middle above Mississippi. My geography is bad is worse than my streams. Okay? To the Midwest was covered by a shallow, couple hundred feet deep, inland sea that came up through the Gulf. Not that long ago, again, geologically speaking. So this is nothing. This is very easy for Mother Nature to do. And if we're helping her along, greasing the wheels, as they say, she'll be more than happy to do that. And again, just think about where your favorite states are. You need a scuba kit to go to Disney World. Houston, gone. We've already talked about Manhattan. Again, next time you go to Manhattan, make your way to one of the coasts. You're at maximum like 15 feet above the ocean. Okay? It ain't high. Now, you're used to the beach. Obviously, the beach is at the ocean, but that's a major freaking city. Like 10 to 20 feet above sea level. Again, I exaggerated a little bit just there. There are points where it is at sea. If you go down to Battery Park, you're at sea level. So New York's right on that board. Boston's gone. We don't care about Boston, though, right? You guys are New Yorkers. At any rate. So, quite possible. But not for your kids. Not for your kids' kids. And it's hard to think that far ahead. We're going to see continued encroachment, don't get me wrong. But probably not. Now, I did say that the switches to warm were rather dramatic, at least based on previous records, but it's probably not going to come on. That prove me wrong. 30 years, you email me. God willing, we're all still alive. You say, hey, Professor G, you were wrong. My parents' condo is totally underwater now. You saw 2.5 million years ago on another slide. That's when our most recent ice age started. Okay? It's also called the Pleistocene. if your teacher made you do geologic timescale stuff, you might remember quite unfondly all of those names. Pleistocene is in the Quaternary period. We live, as you're going to see in a moment, in something called the Holocene. Flesh. All of those are in a bigger era. We're in the Cenozoic era. I remember hearing that word. The Pleistocene ended, as we said, with the glaciers retreating about 11,700 years ago. And as I've said many times, that's a little too specific for me, because it's really totally about latitude there, and even then some. And it was more or less exactly as you picture it in some movies. We had a whole bunch of critters that aren't around now. Okay? You want to talk about whether we hunted them into extinction, or just the weather changed, or a combination of both, sure. You don't even have to look at the glacial boundaries. Just go and look at, what is it, La Brea, tar pits in LA, okay, nowhere near the glaciers. And we've got the same critters preserved in there. They got stuck going down for water, probably water, nasty water, but water nonetheless, was all around there. So these watering holes they go down to, and somebody comes and startles them, they walk in farther than they should, or the water puddle's a little further in than it used to be. They got stuck in there. So we had all kinds of critters, and, you know, combination of a handful of things, hunting and climate change. You don't want to walk around with fur coats like that in, you know, summer in New York nowadays. Just wasn't right for them. So, the saber-toothed kitty cats, of course, long gone. Dire wolf's been in the news recently. I think we talked about how that's not really a dire wolf, but we'll let them have fun. Zebras, we used to have zebras. That's why I studied zebras of Nebraska when I was in grad school. So all kinds of cool stuff used to live here. Now I told you we'd get back to the importance of the fact that the coastline was a lot lower. You probably have heard about the land bridge, right? Across the Bering Sea from very, very, very northern Asia, otherwise known as Russia, across into Canada. So I always just assumed that they came down the west side of the Rockies, right? That would make sense. The Rockies do kind of peter out a little bit as you get into Canada. In America, they're fairly prominent. There's all those stories you hear about gold rush days and pioneer days and whatever, the problems they had getting through the Rockies. We know that's an issue. So maybe just because of that or whatever, what I thought was common sense, I just assumed they came down the west coast and populated America from there. How they got across the Rockies after that, I don't know, I didn't care. But when they actually look at the data, smart thing to do, science and all that, you guys may or may not know about the Clovis population. That is currently one of the earliest civilizations they're given credit to. That's on the east side of the Rockies. So that was a whole new predicament. And what they put forward then, and I love how they gave, you know, nowadays you have the Bering Sea and the Bering Straits up there. All right. Beringia. Let's just conjugate a word we already have and make a country out of it. Sure, continent out of it. So up there in Beringia, these guys came across, and arguably critters as well, but that's another complicated story, came across through this ice-free corridor that they have some evidence for existed. There's another smaller ice sheet called the Cordilleran to the west of the Laurentide, but this is how they're arguing the Clovis got there, and the Folsom as well. You don't hear too much about the Folsom, but the Clovis at any rate. The other thing I tend to talk about when a topic comes up is how much Native American West Coast, because arguably Clovis is not West Coast, but the legit West Coast natives, much of their culture reflects the Pacific Island culture. You see it in the art very easily. Again, that Natural History Museum I was talking about on the west side of Central Park. If you leave the fossils and critters and go into some of the archaeology stuff, you'd think you were looking again at Hawaii and Pacific Islands. The similarities are striking. There is also by boats. It's the last bullet point here. They're still working on this one. I don't know why they're having a hard time with carbon dating or whatever, but there is a good argument going that we were actually populated first by folks that came from these islands and came ashore a good arguably 5,000 years earlier than the Clovis setup. Now, with archaeology, with paleontology, with any of this ancient history stuff, finding these things is hard, needle in the haystack kind of stuff. There were many other civilizations that we probably don't have records of, so on and so forth. These guys just happen to be preserved. And that's sort of always that caveat. They don't, again, the folks in charge of Clovis aren't going to point out, well, yeah, there was probably earlier ones, but I'm not going to talk about that because this is what I'm making my life on. This is what I'm making my money on. They're not, there's an asterisk and a small little footnote that says, as far as we found, but we're not those people, so we can point out that issue because it doesn't always get brought up. So there's that. And again, not to poo-poo either of these ideas, but as I said, I studied zebras from Nebraska. The zebras in Nebraska that I studied were about 2 million years old. All right? So if we're putting the land bridge open at this point in time, we've also potentially got critters coming across with these humans, no question about that. But how do we get them there 2 million years before that? And of course, there's all kinds of evolution arguments you can have about coevolution this and coevolution that, but you still have to populate it somehow. So those species and all those critters we showed you, the woolly mammoths, the saber-tooths, the zebras, all the gazelle-looking things that we had, they came across at a different time. And like I said, I don't really have that in my memory banks right now, but that is certainly a direction that I would, God willing, I have some free time one of these days, would wonder about, because we've got animal fossils way before that, and not talking about dinosaurs. Dinosaurs were back when Pangea was assembled, so there's easy access to everywhere when you got Pangea assembled. If they could get across those vast inland deserts, really, because you're nowhere near the coastlines at that point. But we're, a couple hundred million years after that. We're talking about mammals now. So there's other stuff going on. And again, it's left out of the conversation to simplify things. And I'm hoping I'm not confusing you. I'm trying to add, sort of color commentary, if you would. But since we're talking about stuff like this, and hopefully part of that still stays with you. As little kids, we love finding arrowheads and all that stuff, let alone fossils. And sometimes it stays with you as you go into adulthood. This is going to take a minute to load up. And for it to work, I have to, for the work for the recording, I've got to stop this. That way all your classmates that aren't here, or you when you're reviewing this lecture, will be able to see it on the recording. So what's going on here, again, is probably somebody's master's, if not their doctorate. They're tracking from deposits. This should start moving again. There it goes. So we're 21,000 years ago and counting down. The brownish yellow is land, okay? And when you start to see the blue, that's water coming in, indicating different depths. So this is showing you that by 8,000 years ago, I think I caught it at 8,000, there was a gap. So the bridge itself is closed off. There's modern coastline. It's a lot closer than you'd think. They used to teach Sarah Palin, I think it was, about yelling across to Russia and whatever. Almost. So watch it again here. It's coming down. It's pinching right through the middle. Yeah, even 10,000, it was shallow. Who knows what shallow is? Ice, I-S-E. Okay, so this is not made in America. So the different colors imply depths. Anywho, nothing you need to memorize for a test, just again trying to show you some cool stuff for some of you. All right. Let's close this, or stop it at any rate. Go to stop. PowerPoint. All right, so after we left the Ice Age, we put an arbitrary mark here. It's not like Mother Nature said, okay, it's time to start a new period or a new epoch. There was no bell ringing. We drew the line. All right, the Holocene. That's current time. Began about 11,000 years ago, what we call post-glacial, and what we have is truly modern humans kicked in. We were able to start all of that important stuff that you learned about in Western Civ, okay? And arguably, depending on who you talk to, we have a now subspecies. You know your Homo sapien. There's actually Homo sapiens sapien. Again, what we call truly modern humans. Well, that, as they say, is history. Speaking of humans, I did want to take yet just another moment. Oh, is this going to work in this field? I got to go into the presentation just to leave the presentation. Bada bing. Where is it? Where is it? Right here. So I want to talk about, you've heard the word hominid, right? That's the word that they use to refer to our line. We have Homo sapiens at the top there, all right, and modern humans. Excuse me, it's not broken down time-wise very much. Again, there's not a whole lot of point to doing that. But some other words on here that you might know. You probably don't know Ardipithecus, okay, down there at the bottom. But Australopithecus you might have heard of. There's Africanus, Afarensis, Anamensis. These are all different species of Australopithecus. Now, again, these are not all direct line descendants. Okay, it doesn't quite work that way. These are a lot of branches. Picture a tree, picture a rake. Okay, a tree is better because sometimes you do have something growing off of a branch. A rake is just all spread out. So picture a tree. Some of these lines did lead to others. Some of these lines bred together. We have evidence for sure because there's a huge chunk of our population that has Neanderthal DNA in them. I don't think we have direct evidence that any of these other guys interbred, but arguably if one did, others could. So nowadays they throw Neanderthal under Homo. So it's Homo neanderthalis. This doesn't show that, but that's the last I heard about it. Homo heidelbergensis, you see that capital H, Homo erectus, you heard of them obviously. Homo antecessor, they weren't really trying there, just fancied up ancestor. Ergaster, Sabita, most people have heard. Homo habilis gets a lot of press. But you see some other timestamps there. Prometheus came down, gave us some fire. All right, earliest language going back 2 million years. That's not what they taught you in Western Civ. I'd be interested to see what that is because they have earliest rock art way up at 500,000 is that dash between. These are millions of years. So 500,000 is right where the P in Pleistocene is. So you're looking at 100,000 years ago maybe for earliest rock art. 200,000 probably. But to have language, we have to have some evidence that there was language. So what are they talking about there? Stone tools. Okay, shows up very early. We're becoming less and less impressed with tools as a stamp. Now that we're finding that birds use tools. All right, there's little birds out there that will grab a twig to get insects out of a hole that they can't reach with their beaks because they weren't on Darwin's island to grow long beaks, right? We could have used evolution like that. All right, anyhow, that was a joke, by the way. But we're seeing more and more organisms using tools. The great apes use tools like crazy. So that was a huge thing early on. Wow, we found stone tools and they're this old. That is amazing. And that is cool. Don't get me wrong. But I'm not entirely sure that that's indicative, is as indicative of intelligence or something therein as we once gave it credit for. But at any rate, so the Devisonians, the Heidelbergensis, is, if you follow this stuff, you may have heard about the Hobbit ones that they found. That was, and I knew this the other day when I was talking about it, I think it's the Denisovians are the Hobbits ones. It's just a new line. They're rather short people, so they called them Hobbits. Hello, why are we doing this? I don't know why it doesn't go to screensaver. So at any rate, so just a little bit of perspective. We don't really talk, this is an anthropology class, all right? But since we came into the Ice Age, and one of the things that happened with the Ice Age was we are a species, okay? And we've spent this entire time talking about species and niches and food webs, and you hear about how we've hunted this out of extinction and this. There was a point when we were a lot more in nature than we currently are, because remember, I've been arguing that all semester. We could build air conditioners, heaters, whatever. We could bring water from nowhere near a water source. We could do all these amazing things, all right? And that's great, but that kind of puts us out of the nature. If anything, that's been one of my common themes. Well, there was a point when we were nature, okay? At least a much bigger chunk of it. And so that's why we kind of ended up here. Questions, comments, concerns? Cool. I had somebody walk out in one of my classes the other day, right around when I was talking about this stuff, and I saw them in lab afterwards, and I'm like, was it something I said? I'm like, what? Was it something I said? What do you mean? I said, when you left class the other day. They're like, oh, no, I had a doctor's appointment. I'm like, oh. I said, there's a lot of folks, that get flustered when we talk about evolution. I thought it was just sort of like, oh, God, no, I'm so sorry, I didn't mean. So, it is a touchy subject for some people. And, here's my sources. I don't expect you to challenge me on them, but again, if you wanted to follow through on any of this stuff, follow up on any of this stuff, there's where it came from. But at any rate, so it's just kind of funny, just like right in the middle of that conversation, somebody walked out of the room like, oh my God, what did I say? But